Hi everyone, good afternoon. Thanks for joining this session. My name is Íñigo Alonso. I'm a principal architect in the customer experience team organization in Cisco. I have a multi-year career at Cisco. I've worked as a professional services engineer and architect for many years. My recent years have been, since the acquisition of Viptel, I've been working more on SD-WAN projects, SD-WAN deployments. And it's through these SD-WAN deployments that I started to get into, contact or exposure to cloud. So what, a few years ago was more of exploration of how to connect an SD-WAN network to the cloud. Has been evolving, and actually, particularly last year, I've been involved in a few projects and customer conversations around really multi-cloud networking. So we're going from how do we connect to how do we provide a multi-cloud network. And as you know from other sessions probably by now, right, there is this WebEx space. You can use the WebEx app to interact. This is a new session, so really appreciate if you can spend time to provide feedback on how it went and also your thoughts. I think we'll have maybe time for questions at the end, but otherwise I'm going to be around the next couple of days, so I'm open as well to meet. Don't hesitate to request at the media engineer or ping me over this Cisco Events app. I'd be happy to hear feedback and also experiences, right, with multi-cloud networking. Okay. I've structured the presentation in 4 points. First, I'll start to try to provide an introduction, setting the stage, and then it's more of an abstract or generic session. And what I've tried to do is look at cloud networking constructs in a generic manner. So try to put together a topology that reflects currently how people build those networking topologies in the cloud. Then when we look at a multi-cloud network, we also need to first take a moment to look into how we connect to the clouds, right? We have our enterprise network, we have different clouds. How do we set up that transport between the different environments, right? Public cloud. So I have a brief section about that. And then, what I've done is put together, multi-cloud network topologies. So based on what we're seeing in terms of customer solutions, customer designs, and these two types of approaches, right? What I've called traditional in the presentation, which would actually be non-SDN, and then an SDN approach. So what do I mean, right, by traditional SDN? So SDN is essentially a controller-based overlay, right? I'm coming from an SD-WAN background, so for me it's these SD-WAN controllers and an overlay that you can use to interconnect all of your different private public cloud environments. And that would be opposed to a more of a traditional, or actually better to say a non-SDN approach, where you use the native cloud constructs and then you provide that connectivity to your on-prem. Now, here, I think it's important when we look at this multi-cloud networking is to set a bit the context, right? So, because there are many ways in which you can be using the cloud, you can connect to it. Here, I'm really focusing on the use case of a multi-cloud network where there is this need to extend to the public cloud the control of the infrastructure. What I mean is we want to not treat, and I've seen a few cases where the cloud deployments are like, I'm not going to say strangers, but foreign objects. We want the cloud to be integrated with our on-prem applications between clouds so that we foster collaboration and that we permit this more of better communication between our different applications wherever they are deployed. So it's public cloud as an extension of the private IT environment. And obviously, when you talk about cloud, you want the cloud benefits without the compromising on security, on other aspects, or monitoring, management, compliance. And the focus, so what I've focused on more, and this is coming from my customer experience and also partners, is what I would call the private app-to-app communication, right? So it doesn't matter where we have our applications, on-prem, on the cloud, irrespective of the cloud providers. We want that end-to-end communication to be provided through a single network solution with as few, or a simple path as possible, right? So that we are not going through a VPN on an external DMZ, then through 2 or 3 layers of firewalls, and depending on the region where you are, we really want to provide an homogeneous experience. And in this context, I think the key question, at least that's the question I've come across, is, right, we have this problem, we have this situation. Can we build this multi-cloud network using traditional mechanisms or non-SDN? Or is there a case for SDN? So should we, can we, does it provide value? So this is kind of the theme for the presentation. So this how to say, evaluation or assessment of whether an SDN is suitable and provides value for the multi-cloud network, you also need to take into account all the requirements that typically come with this type of solution. So if you've done networking or IT designs, right, many of these criteria that I've mentioned here, I've listed, I'm going to cover them all, but all comes, right, all these are requirements that we need to meet. We need to look at the performance, how we scale. You know, you're connecting to the cloud, you need to be able to scale out or scale up. You need to have visibility end-to-end. And I think the one that maybe is more, how to say, influencing in the context of the cloud is, I think, the last one before the in the list is this cloud-native end-user experience. So this is something I've consistently heard. You know, yeah, maybe it's fine that we go for an SDN. It doesn't matter. You know, our multi-cloud network needs to fit with the DevOps user experience. It needs to be easy to consume. This application deployment in the cloud is nowadays, you have organizations that are mature. They have this service catalog. DevOps request an environment. They provide what they need, and there is these templates. They get their environment. They get and the connectivity is part of that. So it all needs to be easy to consume, so that there is no delaying or there is any extra work or manual interventions that are needed. So we need to have this, I think, to take this into account when we look at a multi-cloud network solution. So now, this is setting the stage. I hope that this kind of resonates and makes sense. What I'm going to do now is walk over, like I said, so I'm going to walk over a generic cloud networking topology. So this is always a bit risky, right, to generalize, because you kind of miss on the details, and then implementations, and I will point that out, between cloud providers differ. But I think there is a case for, there is a possibility of generalizing. So what is the starting building block of networking in the cloud is the virtual data center, right? VPC on AWS, VNet on Azure, VPC on GCP. So this is like a mini data center where you deploy your instances or your workloads, your endpoints that provides, so you have this virtual environment, mini data center on the cloud infrastructure that provides you connectivity for your instances. This is the starting point. You get subnets, filtering, and this basic connectivity allows you to create an environment where these instances, for instance shown here, communicate. And one of these, the first services that these virtual data centers provide is connectivity to external networks, whether that's the internet or the remote site or an enterprise network. These building blocks, you give you, on one hand, internet connectivity, and that could be just outbound connectivity to get packages, or it could be, you get assigned public IP addresses, so you can expose services to the outside world. And then you have the VPN type of service where you can connect via private or public endpoints, right, over the internet or over these direct connections that they provide. You get your virtual data center. At the end, what you get with this is your IP ranges in that virtual data center. They are able to communicate with these external destinations. And then in terms of how the routing works in this virtual data center, you have typically this routing function where you have some control. You can manipulate routing. You can, if you're using a VPN, then it can advertise routes that are being learned. So there is some degree of control that you have there to integrate with external destinations. Then how do you, so imagine now that you have multiple virtual data centers, how do you connect them, right? The cloud providers have this typically this service of peering between virtual data centers, VPC peering or VNet peering. It's not very common and it doesn't scale. So the more common approach is to use the concept of a cloud transit. So you have your virtual data centers being deployed. You interconnect them with a cloud transit. With this, you achieve hub and spoke connectivity model. And then in this cloud transit, whether you build them yourself or you use the cloud native cloud transit gateway in AWS, you have control over the routing, right? You can start putting, in AWS, for instance, you can have a route per attachment of these virtual data centers, and you can, kind of control how that communication flows. This is all connectivity, right, between virtual data centers. So we have the virtual data centers, the cloud transit, and this cloud transit, similarly to the virtual data center, can also be connected to external destinations over VPN. Okay, very common topology. Now, obviously, this differs between the cloud providers how they implement it. One additional feature that comes into place in the cloud, and I think it's probably different to what we get with private data centers, is this private access to services. This is it's an interesting feature. At least I find it interesting. It's a way for you have a virtual data center, you've deployed your application, these applications need to talk to other services. You don't need to use a cloud transit to provide that connectivity. You can create these endpoints. They have maybe different names in the cloud providers, but the concept is very similar. You create an endpoint that is part of your virtual data center, and that gives you like a pipe, a connection to a public service of the cloud provider, so a PaaS offering, a database, a file system. Or you can use this as well to expose services between separate different virtual data centers. To the point of you're also able, and I've seen this in one customer, you can use this across organizations. So it's really quite powerful. You can create an endpoint, you expose it's a virtual IP address somewhere in another account, and then they have access to whatever service you're exposing there. So this is, I think, it's quite important because this can also be used for a multi-cloud, application-to-application communication, right? So the cloud transit, the private access to services, and then another block that is very common. It's nothing special. It's just a virtual data center that you use for a particular purpose. Is shared services. So this is about common services that are required by multiple of these application environments or virtual data centers. You want to put in the firewalling, you want to provide the DNS centralized or other services. Typically, how this is done is you create an environment dedicated for that, or multiple, right? Because you can have them. I'm showing here only one in the slide, but obviously you can have multiple of them to host these services, and then your virtual data centers, if they need any of these services, they will go to the shared services via the transit, the cloud transit. And this can also be extended to the private service access that I showed. So you can expose your endpoints into these shared services, so you get control and sharing. So multiple environments that need to access the same database, they would be doing through the shared services. Many applications, and this is very common. So we have this cloud transit, shared services, virtual data centers. If you then have a cloud deployment multi-region, your topology is probably going to look something like this. It's a very generic diagram. I recognize that, but it's somehow accurate as well. And these shared services, it could be regional, you could be centralized for the cloud provider. This is a generic diagram showing that with these constructs, the transit, the virtual data center, the shared services, then you get your modular design, repeatable. It's kind of common as well across cloud service providers, and is using fully the cloud native constructs. So at the moment, I haven't inserted anything. Obviously, shared services, you could be having firewall instances, you could be having other types of inspection devices or specialized services, but this is using the cloud native constructs for networking. With this, you achieve common traffic patterns. You can replicate this topology across cloud service providers, and with the cloud transit, you also get access or communication to external services or destinations. One example is that flow to the internet. Normally, you wouldn't connect applications in a virtual data center to the internet directly. You would be looking at putting maybe an outbound proxy. So now limitations, right? Again, very high level picture. What kind of limitations we find when using these cloud native constructs? There are a few. I think one of the key aspects is that the implementation differs across cloud service providers. So If you're working with AWS Transit Gateway, that's going to be different than Azure VNets. And then in GCP, you probably create your transit VPC, you use the Google Cloud Router, and then you get all of these different behaviors when it comes to BGP, for instance, right? They have different ways of doing things. One will do ECMP, the other one will maybe use the metric. No, the metric is the AS path maybe, or the MED. So it's kind of, you need to go back to them and do detailed designs to achieve the same thing. There are cost factors as well that can vary. So I'm excluding cost because it's complicated. You probably need a separate session just on cost factors when using the cloud. And I think at the end is, there is also the limited control and visibility, not to forget, because all of these constructs, they are kind of a PaaS service, right? You get access to them, you can set routing, you can create the VPN connections, you can advertise routes, but it's not that you have access to them and see how they work. You cannot do a, trace route from one of these cloud transit blocks or the virtual data center. And there's also a bit the question on scaling, though performance-wise, they're fine. At the end, I think if we go now to the context of multi-cloud, and this is what I have in my next slide, they are not, these cloud transits work quite well within the cloud, but then there is not even probably documentation, there's no documentation or very little of how you would use them to interconnect different clouds. So they will tell you, hey, this is how you create a VPN, how you connect to your on-prem network, but they don't give you much guidance. I've seen, I think GCP has a couple of articles on how to set up a VPN to AWS or to Azure, but then how do you design a multi-region, multi-cloud network based on those constructs? And I think it goes back now to the question of how do we build this, first of all, and then here is there a case for SDN? Should we continue this way? Should we look at an SDN overlay with controllers to help us interconnecting it and creating this end-to-end network? Before that, so that's kind of the key question, and I will show topologies. I just want to, like I said at the beginning, I want to quickly jump into the transport options to the cloud. Right? From your enterprise network, what you can use to connect to the cloud. There are various options. Probably this list is not even complete because some of these, for instance, direct connection you can do directly, or you can have a partner connection. At the end, I think what is important from a multi-cloud networking perspective is to understand that we can use any of these. The decision of what to use of these transports, whether the internet, public peering, so you go to a cloud, a colocation facility, and you can, your enterprise network, you can peer to the cloud provider, exchange public IP prefixes, and then you have this direct public IP-based connection in the colo or the CNF, or you can use then the direct connection options, whether direct link or direct connection, or a programmable fabric like SDCI, or even your service provider might give you these layer 3 VPNs to connect to the cloud. So all of these options, at the end, the decision factor is not going to be, do you want to build a multi-cloud network? You can build it with any of them. The decision is typically amount of traffic, SLAs, contractual relation, number of sites that you need, and all of these, more of the transport. Typically, a direct connection starts to be interesting if you have a high volume. So there might be eventually locations, but this is better. And the part that I've tried to illustrate in the next slide is that at the end, with all of these options, one way or another, what you can get is your virtual data centers in the cloud can get connectivity to your enterprise network in multiple sites. This is just showing one type of connection, but you can aggregate in this cloud transit multiple of them. So you can use one, many options of one. You can have multiple VPNs on the cloud transit, or you can have multiple direct connections from different cloud providers to your same site. There are many options, but it's all becoming, at the end, your transport to the cloud that will be part of your overall multi-cloud network. I hope that makes sense. There are a couple of sessions. I have one in the reference at the end that Cisco Live sessions are going into more details onto these options, right? And how to secure them, how you can use SDCI fabric for connection to the cloud. All right. So very brief look into the transport to the cloud, how you connect to the cloud. Now, next part is start with the multi-cloud network topology. So this is a progressive build, right, of at least the common topologies that I've seen, starting with the non-SDN. So essentially, if you have cloud deployment, so start with two cloud service providers in same region or more or less aligned region. You pick a site, can be a data center. So start with a data center where you're going to be connecting these cloud environments through the cloud transit into your on-premise network. Okay? You're going to be picking a site that is regionally close, and you're going to be aggregating that connectivity in that size where you can enforce your networking, security, whatever else you need. And with this, you have control connectivity from cloud to your on-prem, and then cloud to cloud. Okay? Pretty simple topology. Now, what is, at least what I'm saying, I think is what is becoming an established trend is that these sites, there's this trend, right, of now going from out of an enterprise network having data centers where you aggregate connectivity and internet breakout and access to services. This is all moving to co-location facilities. At least, most of the customers I've worked with, they are there, or they're moving to that, or they have plans to move to that. Why is that? It's because you get in these co-location facilities, right, this large size where you have service providers, content providers, SaaS providers, connectivity providers, even the cloud providers. Everyone is there, right? It's these huge hubs of, I've never been to anyone, but I guess it's an impressive site where you have all of this connectivity that you can get, very high speed. Everyone is there, so it's like a direct connection to all of these different content and service providers. So it makes sense to, and connecting to the cloud, let's go into these huge meet-me points and connect to the cloud. And I can bring into the site either via internet. I'm showing here internet or a direct connection. It's not, there is not much difference between doing one way or the other from a connectivity, end-to-end connectivity perspective. So co-location facilities, pretty established trend. What happens here on the cloud? So I've said, you have connectivity from the cloud controlled to on-prem, cloud to cloud. What happens within that, each individual cloud? So we rely on, with this model, we rely on shared services, on the cloud transit to control the communication, the collaboration between environments in the same cloud provider. Now, if we move to a multi-region design, then, so I've put in here two cloud providers, two regions. They are connecting to two sites, one with internet, one with direct connect. This model of aggregating connectivity on co-location facilities is, it's being extended not just for the cloud, but for other, for creating this network backbone based on these co-location facilities, connect the enterprise sites. And with this, you have, this overall backbone where you can then aggregate the connectivity to the cloud providers. These sites, you have seen many names used. In Cisco IT, we have this cloud port. This is referenced as cloud port, and the Cisco IT backbone is now based on these cloud ports. I've seen customers referring to this network hub as a service exchange. There are even cloud connectivity providers looking at, naming it cloud service exchange. It's very similar concept. It's going to these locations, putting in the infrastructure to provide connectivity, aggregating remote sites, your data centers, headquarters, and then cloud connectivity, so you have this ideal place to provide end-to-end connectivity. And I think there are also, service providers, everyone is looking into this type of approach of, backbone of sites, the ones in the middle. Now, this is the more common topology that I'm seeing, and this I would call non-SDN, because it's using the cloud building blocks. I'm connecting through a standard VPN, IPsec, or BGP over direct connections. How do I turn this into an overlay? So this is where I guess I put my SD1 hat, and I look at this and say, okay, there's 1, 2, 3, 4, 8, 12 sites. So I'm going to do some PowerPoint magic and convert it into an SDN overlay. Right? I've just brought up those routers, and they become, instead of direct connections where I do BGP, I just have this overlay with controllers. And I am not really changing much, right? The sites are the same. I can provide the same services. And I am extending now, so with this, I'm extending my overlay to the cloud. And there are ways you can splash this as I did, as I've done, or you can, if you already have an overlay in your enterprise network, your colocation facilities, you can extend it to the cloud. That's something we've seen commonly with SD-WAN. You could also think about the reverse directions on the multi-cloud environment. You're looking for an overlay, and then you will want to extend it to on-prem. Either way, this is where I think we have the comparison, right? The traditional method with the cloud constructs, or an overlay, an SDN overlay, so controllers and an overlay network. So the question here is there a case for this? What do I gain? What do I lose? What's it gonna get me, right? Or should I do this? So the next slides, and will be the next 5-6 slides until the end, is I'm just looking into what SDN could bring. So it's a collection of what SDN can currently provide, an SDN solution, what it could bring, and then things that are being explored or maybe looking to the future. And it's a combination of what is available with Cisco and what I've seen other vendors and solutions positioning or offering. So when you first probably show this or see this in a conversation, is okay, what is SDN going to bring at a very high level? It's going to be, you're going to have first of all, you don't lose anything compared to the traditional method. So the services change, the on-prem connectivity, the connectivity on the cloud is all provided with SDN. So at most, if you have a mature SDN solution, you're not really losing or causing any issues or limitations into what you had with a non-SDN approach. The SDN approach will support any transport, right? So I showed those connections that can be public or private. The SDN will work over those connections to the cloud, whatever you have in there. And one thing that you get by extending your SDN to the virtual world is now you're normalizing that connectivity to the cloud provider. So you are putting these virtual routers, virtual form factor, that are going to terminate, and you're going to be able to control now homogeneously, right? Because this is what you have with a controller-based overlay. You have a centralized controller, and you can normalize your end-to-end multi-cloud connectivity. What's the first reactions of people when it's the first time they see this is, this is another solution, right? It's additional technology and skills. What is the performance? And then the question comes immediately as well, what is the programmability and integrations in the cloud, right? Is this going to help me speed up, or is it going to slow me down? And what kind of cloud consumption model this is going to bring? This is a starting point. Then, like I said, I'm looked into the added value of SDN, and there are a few key features that you can think of. Again, SD-WAN based, but also other solutions. First of all is now you have this SDN overlay, multi-cloud. You have multiple transport paths because you're going to need them, right? Whether it's a direct connection, internet, whatever you're using. You could even have a combination of them. I've seen environments where direct connection is primary and then they want to use the internet as backup. Cisco IT, for instance, is doing this. So we need this capability of monitoring the path, of understanding the performance, and then being able to select dynamically. With a traditional approach, we use VPNs, BGP. You do have path failure detection, but you don't have the capabilities of measuring across cloud providers, across all the backbone that you're using, all of these paths. That's kind of already available. So, underlay on overlay path measurements end to end, and another factor another aspect that comes into play is you have these private or public links to the cloud, but when you're in a multi-region, multi-cloud environment, you can also think about using the cloud backbones. Sometimes the cloud backbones have better performance or are better suited for the communication that you need. So with an overlay, you're extending there your reach, and now you can combine your measurements of underlay, overlay, the cloud providers, and select the best path at the moment, at each moment. And then how much farther can this go? So you could think about, okay, we have the SDN network is measuring itself, its metrics. SD1 is using BFD. You can use some techniques for underlay measurement. You could actually enrich that with other more targeted probes, like Thousand Eyes can do, right? Thousand Eyes can replicate a user or an application exchange, provide you metrics. So you could maybe start adding that into the equation, right? Of how you select, how you monitor the path. You could even have, and we have it already, right? We have the telemetry from SaaS providers, so we provide information about how an application is performing and can help selecting the path. So all of this put together gives you, I think, a quite rich or quite powerful engine for selecting the path that you need or the traffic should take. Can combine it with business-driven or application architecture-driven options like I always need to use this path because it's shortest and this is what I need for this application. For others, I can select based on other performance data. And another kind of trend that is coming is combining all of it with analytics. So now you can have maybe an external system processing all of these metrics and data and give you information about, okay, don't wait for this to go under the threshold. Start shifting traffic because we see the trend, right? And we've seen it in the past, so it's repeating. Let's just shift traffic. It's more of a more advanced, right, predictive networking, but I don't think that we're that far from there. So I think a key value of that SDN can bring is across all these cloud providers, all these transport connections, path monitoring, path selection with an advanced policy engine. What else can it bring? So because I showed in my first diagram, I show the overlay terminating kind of at the edge, right, appearing with the transit. The overlay could also go into the virtual data centers. So you can have your routing function in there that will give you tighter control, right? You're not dependent on a cloud admin correctly configured the virtual data center. You can put your routing function in there. And there are vendors already trying that on a shared services environment. And moreover, you can even think about going even higher into the application layer, right? So if you think about a Kubernetes cluster, a mesh, you could have either something monitoring that or even a routing function in there, kind of connected to the underlay so that you can serve better that application. So these are the extension to the virtual data centers. Is something that, it's maybe more common. The combination with application layer is probably something that we'll see coming. The other aspect when you think about a multi-cloud networking is if you compare non-SDN with SDN. With a non-SDN, you can manipulate routing advertisements, you can influence paths, but you don't have maybe the complete flexibility that you will get with a policy engine like is common in SDN to determine your topologies, to determine maybe hub and spoke within across regions, full mesh between regions, this use of the cloud service provider's backbone. All of that is policy as well that you can define with SDN. And then you have the end-to-end segmentation. You can do it with both non-SDN and SDN. I think with SDN you get the normalization, right? It's all the way to the cloud providers that you have a consistent and across cloud providers segmentation. What else? Maybe going further up into capabilities of SDN, there is this application recognition. So we have in Cisco the MBAR engine. We have this service here at the bottom of the slide called SDAVC. This is an engine that can distribute application information to the network. So it can aggregate what is being learned. It has these application packages. It will distribute the information. So we have this application recognition, which can be combined with the path monitoring, path selection policies, with your overall policy engines. All that you can have truly down to the individual application policies for selecting the path, for selecting where the traffic is directed to. And this is very powerful, right? Because in a multi-cloud environment, then you're sure that you're using that application information consistently and you're learning from all the cloud providers. And then on top of that, we have this development that is shown here, this use case of Google Cloud Directory, where we can or the controller can read the app information that DevOps teams are going to be publishing. So they will publish information of the endpoint and IP address you've just created. Oops, I've touched something. Okay, sorry for that. So they will publish this information, and then as part of the metadata that they include in the application information, they can tell the network what type of traffic this is, what category. And this has been previously agreed. So from a networking perspective, in this overlay, we can define policies based on application or traffic types or categories. And then from a DevOps perspective is, okay, I publish an application here in this registry, and then I include the metadata based on the agreed categories with the network team. So this is really linking now and enhancing the collaboration of DevOps and NetOps. And in a multi-cloud environment, this is something that you can achieve with an SDN. Because if you have different capabilities, different cloud providers, then you're going to be, kind of having to adapt if they can provide application type of recognition and policies on networking, plus the consistency across cloud providers. One before the last is programmability, right? So this is a key aspect, like I said at the beginning. All of this needs to be, when you think of a multi-cloud network, you need to be able to provide the connectivity, the services to DevOps that is easy to consume, programmable. On the SDN side, if you look at something like SD1, right, we have, you see here in this diagram, the scope of automation. I took this slide from another session, which talks about SDCI, how the hybrid cloud and the connectivity to the cloud is evolving. And you see here the capabilities that we have in a single controller to automate end-to-end the entire path from on-premises through the SDCI fabric all the way to the cloud. Is this sufficient? Is this covering everything? Possibly not. You're going to be typically amending or complementing this automation with cloud specific, so to build these shared services, to provide the connectivity in the cloud transit. But this is really getting to the place where we want to be. And this obviously needs additional development to get to end-to-end full connectivity provisioning in an automated fashion, so that DevOps can ideally go to service portal, say, I need this type of service with connectivity to X, Y, Z applications and endpoints and services, and then that gets end-to-end provision for them. Okay. I got this diagram or this slide from a Gartner report. So this is more looking into the feature set, the advanced feature set that SDN can bring into the multi-cloud networking. So selection of a multi-cloud network solution. This is a kind of a checklist, right, of features that you're going to need or want to provide value. And this is what SDN, there are a few things that I've mentioned here. Service mesh is even mentioned. So this is kind of a checklist of networking, security, management. It's all kind of related to the requirements I listed at the beginning. And with this, I think, it's actually quite early. Great, so more of the conclusion, right? So it's data case for SDN in multi-cloud, right? There is, a value, I think, what I've tried to show in the few slides here. With SDN, you can provide this global network, any location, any transport, common management, single management, consistent feature set across all the cloud providers. So there is that kind of plus from an SDN perspective. The advanced features, the policy engine, and the continuous evolution in that front, I think, is also adding to the positive case. The programmability, easy to consume, still needs to evolve to provide the end-to-end. But then on the, when you don't need SDN, well, there could be suitable non-SDN solutions. So, these kind of cloud native constructs, the services change hubs, all of that is a practical and proper way. If you have very determined locations where you need that connectivity and regions, you don't need to be creating an SDN overlay. You can enforce the paths that you need with non-SDN solutions. There is an evolution as well of the cloud native constructs, obviously. So this in continuous evolution. On AWS side, for instance, there is now this ability to define policies for your global WAN network. So it's not that at the moment you add your transit gateways and the connectivity or the routing is going to be static. That's evolving, and you have policy models for defining that connectivity. And yeah, potentially SDN, it's adding flexibility, it's adding complexity and maybe scalability. So that if you think, for instance, of putting routing endpoints in every virtual data center, yeah, there's a question of, okay, how can that scale, right? If you're going to have thousands of endpoints there, how is your overall overlay, your controller is going to manage all of that? And that's, yeah, I think it's, I did also go and ask the artificial intelligence. So I never used this famous ChatGPT. I guess everyone has heard of it. So I tried over the weekend. I created an account. If you haven't used it, I think it's an interesting exercise. So I created my account over the weekend, and then I asked ChatGPT. So I went create the account and asked, just type this. What is the best approach for cloud networking? For multi-cloud networking. And I can show you even, if you're interested, I can show you the thread. You have this dialogue, right? You put a question, you get an answer. It's surprisingly well written, and maybe you can suspect where what is going, what kind of document has been written to put it all together. And then you can be asking more questions about that. It's actually interesting. And well, this is what it says, right? So I guess I'm not too far off. So it says, common recommended approach for multi-cloud networking is to implement a software-defined network that provides centralized network management and consistent policy. And then I continued the dialogue and I said, okay, but what are the drawbacks? And I provided this list here at the bottom. It says, well, potential drawbacks, complexity, interoperability, latency, scalability, security, and cost. So I guess I wasn't too far off with my presentation, but that was an interesting exercise. And last, I browsed the Cisco Live catalog. I also went back to the Cisco Live from 2022. There are some sessions here going into more details of some of the aspects I mentioned. So you have, some sessions about cloud on-ramp with SD-WAN, cloud network controller. So this is the ACI controller, ACI-based controller on the cloud. So this is an example of adding control to the virtual data centers, because the cloud, the ACI controller on the cloud can push security rules, right? Security groups to the endpoint. So there's already a mechanism to influence the routing, the connectivity on the cloud. There is then from the Cisco Live 2022, securing private links. So this goes into the details of all these direct connections. And one that I thought as well quite interesting is this breakup 1002. So this is the Thousand Eyes team did research over some time. So they're probing they're measuring the network performance of the cloud providers. So it's quite interesting because they provide statistics, metrics of intra-region, inter-region, and even between different cloud providers from outside to the cloud and from the cloud to outside. And it was a bit eye-opening because these cloud backbones, we always represent them as a kind of homogeneous cloud, but in the end, they have the physical topology they have. They're bound as well by the regions, and they don't have millions or tens of circuits between different regions. So it's quite interesting to see that this cloud service provider backbone do have different performance depending on where you are, where you're communicating to, and then an SDN overlay, like I kind of showed, can help with that. And I think that's it. Like I said at the beginning, it'd be great to hear from you, feedback, questions, experiences. And actually, we have time. So I was much faster than I thought. We have time for questions, so happy to, Yes?
I think we established that it's a good idea, an SDN controller for cloud networking, but maybe I missed it. Does Cisco have a solution for that?
Oh, okay. So the question is, if you don't hear, the question is, does Cisco have a network controller for multi-cloud networking? We have our SD-WAN solution that you can use for multi-cloud networking. So with the SD-WAN controllers, the vManage and the other controllers, you can create the topology that I've shown in one of the slides, transitioning from kind of traditional to SDN, that topology is based on SD-WAN. So you can use SD-WAN for that type of approach. Sorry?
So DNA center.
No, SD-WAN. So really the vManage controller. And yeah, the automation, so the programmability slide is really based on SD-WAN. So with the vManage controller, you can drive, obviously, the connectivity on premises, right, with the SD-WAN routers. You can also drive, let me go back to that slide, because maybe I went a bit fast. Yeah, so all you see here, right, what's important is this arrow with a scope of automation. So we have, in the SD-WAN vManage, we have workflows to automate the connectivity to the cloud using Megaport and Equinix as SDCI providers. And it's really a 3-click. That's why I wanted to raise it, because we talk about programmability of SDN and overlays, and we have a lot of programmability. We have these workflows that you can use to build that connectivity without having to worry, physically where this is or how this is happening, no manual intervention. So you can go there and request a circuit in Megaport. You can request a virtual router function to be created. That will be your virtual router, and then that will be connected automatically to your circuit, to the cloud, and create this end-to-end connectivity. Plus, we have the cloud on RAM, where you can create transits, so cloud transits on the cloud, and interconnect with your SD-WAN overlay those cloud transits. Yeah, and you can also go further up and connect your virtual data center environments to the cloud transit. Okay. Did that answer? Yeah. Okay. All right. Yes.
I believe that there is a limitation in the throughput when you first deploy VPN tunnels over internet connected to the cloud.
Yeah.
And that's the reason for which most clients migrate, for example, to an express route or a direct connect, because you can get more throughput.
Yeah.
When you create an overlay over that direct connect or express route, are not you getting that limitation on the table again? Or with SD-WAN fabric, you are able to skip that limitation?
So when you create an SD-WAN overlay over a direct connect link, you get a SD-WAN tunnel on top, and you get the throughput that SD-WAN routers can provide. So you will have maybe a physical SD-WAN router or a virtual one on your site, starting the direct connection link, and then your virtual router on the cloud. The performance there is going to depend on CPU, hardware resources of those virtual routers, and you can definitely go over the 1.25 gigs of the cloud. Now, if you then pair those routers with the cloud transit, and if you use an IPsec there, that's where you get your limit throughput again into 125 gigs. With AWS, there is this option of GRE connections, so that you can go up to 5 gigs per second. The common way around this is to have more tunnels being created, so you can scale horizontally.
Yeah, and that's easy to do, or it's not part of the overlay?
It's part of what the overlay can, so an SD-WAN overlay can.
Increase your throughput by increasing the number of tunnels.
Yes, you can, and you can ECMP, right? You can load share your traffic across all of these multiple tunnels. Yeah, that would be the way to scale up. Okay. All right. Anyone else? Any questions? Yeah. Thank you.
So I have many questions, and I really think we can follow up later on. But now I can go is the maximum scale-up number of tunnels can go also the same as the normal size, like 2,000 tunnels, or you can overcome this with the gateway regions as we do with the normal.
Okay. Yeah. So the question is about the scalability of the overlay. In the case of SD-WAN, you do have a factor of maximum tunnels that you can have per router model. And then one way indeed to scale that is to go for a multi-region fabric. And for that, there is a session tomorrow. If you're interested, Jean-Marc Barosset, one of our principal engineers, is going to talk about the multi-region fabric concept in length.
So to follow on this question now.
Yep.
So for every public cloud, there are multiple regions. Do I need a cloud on ramp IaaS for every region, or for one public cloud provider, one node should be enough?
The way in which, so how the regional connectivity works, normally your cloud network topology is going to be using the cloud transit, and the cloud transits are going to be regional. So you can create this mesh of cloud transits in the cloud provider, right, per region, and then you can select which ones you connect. You don't need to connect all of them to your on-prem. It really depends on the end-to-end networking that you need, what size you need to connect. Okay. Good. Yeah.
Can the SD-WAN solution, when it replaces the IPsec overlay, sort of traditional solution, can it replace the ciphers and the security requirements for like government bodies? So IPsec, Diffie-Hellman groups, elliptic curves, that sort of thing. Is it good enough in the security sense to replace the traditional IPsec overlay?
So the question is whether the SD-WAN overlay would comply with strong security requirements. I believe it does. If you have, specifications in terms of cipher suites, or I can double check, but normally it's compliant.
Private key infrastructure.
Sorry?
Like private key infrastructure. Internal certification.
Yeah, the SD-WAN overlay is using PKI infrastructure for all the endpoints. So you have mutual TLS-based authentication, and then that mutual TLS-based authentication, so every router will authenticate to the controller using the TLS certificate of the router and a TLS certificate of the controller. And then that control connection that is set up will be used to distribute the key material for the IPsec. Yeah, IPsec. Yeah. So DTLS is used for control plane, and then IPsec will be used for data plane with the key material that you share over the control plane. Okay. It's should be here. 1 second. It's one of the options for the transport connections to the cloud. Let me go back. Yeah, this software-defined cloud interconnect. So it's a programmable fabric that offers you the capability of building connections to the cloud. So you don't need to physically have the connection. This Equinix or Megaport, they provide you this capability of ordering and getting a link. And then on top, you can have a virtual routing function that will be connected to that link. And that you can then, if you're on AWS, that you can put into a direct connect. So the VPN gateway can get you that connection. The BGP routing will be configured on top. So you're terminating this connection via maybe the next slide. You're ordering that connection that's being terminated in your VPN gateway. You can set that up. That's getting you the private connectivity to your routing function, and then on top of that, you put the BGP to exchange prefixes.
The transit gateway can, not the VPN gateway, the transit gateway can be configured with BGP.
Yeah, absolutely. So the transit gateway will be the terminating point for the this programmable direct connection.
Can I connect my enterprise network to the SDCI provider? So it's a VPN or need to be a direct connection to some colocation? Or?
You need to be on a co-location facility, and you need to have a link towards the SDCI provider.
Okay.
Yeah. But I suggest, there's some reference sessions going into some of the sessions that I've listed. They go into the details of how this is done.
It's basically the same as connecting on direct connect to AWS.
Yeah, it's the same principle. It's just that it's programmable, so you can request it kind of on demand.
Okay.
Yeah. And then they offer compute, so virtualized infrastructure where you can deploy your virtual routers, firewalls for that connection.
Thanks.
Okay. Yeah. I'm sorry?
The use case you present the use case, slide with use case.
At the very beginning, or?
No, at the end.
At the end.
The use case, you present the use case with introduction.
Oh, the application.
Use case summary. Okay. There is a lot of automation because here
you takes DevOps and NetOps must cooperate together, and it's not a manual cooperation. You mean DevOps should register their cloud application in a portal, etc., and you use the information regarding the application to build the configuration of the SDN fabrics. You have an offer. I mean, is it? You have an example of this kind of configuration in the real life?
Yeah, this is based on an existing feature in our vManage, and we're not using a portal. This is a Google Cloud Service Registry. So on the Google Cloud, you can create an application, and then that will be added to a registry. So what we need on the controller is the information of where this registry is, and then the controller is going to be reading the application information published on the registry. Is the Cisco vManage controller. So it's the controller for SD-WAN networks.
Yeah, I understand, but is there to interact specifically with Google? Is it's a feature in the vManage?
Yeah, it's a feature in the vManage to read from a GCP service registry.
Okay. Yeah. And it's a recent feature? Do you have an example about this kind of interaction?
Yeah, I can provide more details. I mean, it's relatively recent. I actually worked on the prototype about 2 years ago, and then it's been added into the vManage controller. Yeah.
Because I have this use case, exactly this one.
Yeah, I find this amazing. This is really great because now you can really publish your private, endpoints and ports, and then the network doesn't need to be manually configured. It's just running automatically, distributing the information, and you have defined your policies based on a traffic category. So it's all just coming together very nicely. Yeah. For me, this is how do you call this? A killer. Well, it's a very valuable use case and feature. But I'm not sure that this is common in other cloud providers in terms of these capabilities. But this is definitely.
There was a workshop today doing this in practical, but a public Kubernetes example, not specific for Google. But the same thing you say to push the app.
Yep. Yeah. I think this is gonna be extended because it's really a way to bring NetOps and DevOps together. Yeah.
Is there a similar solution for AWS or Azure?
Something is coming, so I can double check. Yeah. Okay. Yeah.
The other benefit for SDN, I guess, is it's easier to configure encryption, right, on the different links to the multi-cloud.
Yeah, you get, when you create a fabric with SDN, the forming of the tunnels is done automatically. You don't need to be configuring them. But that overhead is probably not the tipping point for going from traditional to SDN. I think it's more these capabilities, right, current, coming, and in future that will really provide value. So where. Without an SDN with SD-WAN, you're going to be using the whatever the cloud providers support, which is typically IPsec with AES 256. That's kind of the de facto standard. And then, depending on the cloud provider, the authentication works in a different manner. So you can have pre-shared key, I think is common, but then they're also looking for certificate-based IPsec setup. You need to see the capabilities of each one. This is where they differ, and then you work on each individual cloud provider to understand how to build that.
Just one question. You don't need a CSR or anything like that, right? You can just directly go to TGW in case of database.
Can you repeat that? Sorry.
You don't need a CSR or something like that.
Yeah, but you need
not
a CSR, a virtual router.
You're going to be deploying virtual routers on the cloud, but this is something that we can also automate. So you can have this deployed automatically, already onboarded into the SDN with a bootstrap configuration. So it's just extended part of the overlay and brought up automatically. But you do need virtual routers, right, to extend your overlay into the cloud. Yeah. Then we're exploring the option of adding this virtual routing function into the virtual data center. So, but it's all going to be additional, and this is one of the challenges, right? Is additional components that you need on the cloud.
I've seen a solution where you can use Cisco box or Cisco virtual router as a transit gateway. Can I use that?
Yeah, this is what I mentioned, where you can build the transit VPC concept, you can build it yourself. But now that there is the cloud-native constructs of cloud transit, it's not very popular.
So if I deploy a 8000V as a transit gateway, for example in AWS, can I use the same virtual router to connect to the overlay?
Yeah, absolutely. Yeah, that was our initial cloud on-ramp for cloud. Was doing this, was creating a transit VPC with Catalyst 8000V routers and then connecting to the VPCs.
Okay,
yeah.
You said that was like the first approach, and what's the approach now? You deploy
the transit gateway, and then
in front of it.
and then a transit VPC connecting to the transit gateway. Yeah. So using the cloud native constructs.
And that's maybe more for AWS, but if you are in Azure, for example, in which you can deploy the virtual hub and within it the router.
So for the case of Azure is on so the workflow will create a V1 hub and then deploy the virtual router as an MVA. So it's peering within the V1 hub and it will peer directly, so it will create the connectivity. Yeah. So this workflows is good because then your edge of the overlay is on the cloud. These workflows have been already ready for you, so you get this the overlay extended to the cloud without having to worry about how that is exactly done. Okay, yeah, thanks all for staying. It's very cold, I know. And looking forward to see you at Cisco Live. Thank you very much.